anything different with me?
Is it your makeup? Did you wear lighter shade of foundation?
No, actually, I didn't wear makeup at all today.
What? But you look flawless.
Oh, that's because I've been drinking lemon water a lot since today.
Is it because they have vitamin C? Vitamin C has brighter skin, right?
Yeah, totally.
Not gonna lie, I wonder how much lemon water you need to drink in a day to get enough vitamin C to brighten your skin.
Me too. By the way, how much vitamin C in the lemon?
Yeah, how do we know?
Guys, we learned this in analytic chemistry. We do it by titration.
Titration?
Before we dive into titrations, let's get to know the application of analytical chemistry. Analytical chemistry is crucial in assessing the nutritional needs of both humans and animals. It allows accurate food composition data to determine dietary intakes, evaluate diet adequacy, and improving human nutrition worldwide. By applying analytical methods, nutritionists can make sure food products contain the necessary dosage of a substance as well as to ensure the safety and result of a food product. Titration is under the branch of volumetric analysis, which is a general term for quantitative chemical analysis. It is usually used to determine the concentration of a sample by measuring the volume of another solution with known concentration to react with it using a suitable indicator. Titration itself is a controlled chemical process, as the amount of a substance in a sample is determined by measuring changes in volume of the known concentration solution.
Okay, so next I will explain why volumetric analysis is important in determining vitamin C in lemon juice. First, volumetric analysis helps determine the exact amount of vitamin C present in the lemon sample through the titration process. Second, it provides accurate and reliable results because the concentration is calculated based on measured volumes of solution. Third, volumetric analysis helps calculate the concentration of vitamin C by using the volume of iodine solution required to reach the endpoint of the titration. Fourth, this method is widely used in food analysis, especially for citrus fruits such as lemon, as well as in pharmaceutical and quality control laboratories. Finally, the endpoint color change makes the experiment easy to observe, which is allowing us to identify when the reaction is complete and obtain accurate measurement.
Now, I will present about titration. What is titration? Titration is an essential method for measuring chemical concentration and checking its purity. There are 5 types of titration. First, acid-base. Second, redox. Third, complexometric. And lastly, argentometric. As seen, we given an example of acid-base titration. Material used in acid-base titration is hydrochloric acid as unknown concentration, sodium hydroxide as known concentration, and phenolphthalein as indicator. Type of titration used in this experiment is a redox titration. Material used in this experiment is vitamin C as unknown concentration, lemon as known concentration, and iodine solution as indicator.
So, the list of apparatus that were used in this experiment will be read and written: 100 ml of beaker, 1 liter of volumetric flask, 250 ml of conical flask, and last but not least, 20 ml of pipette. Okay, now let's move to the preparation of chemicals. The first chemical that need to be prepared was the iodine solution at 0.005 mol per liter. The first step is 2 grams of potassium iodide Ki was taken in a 100 ml beaker and 1.3 grams of iodine was added. 50 ml of distilled water was added and swirled for 20 minutes till iodine was fully dissolved. The iodine was then transferred to a 1 liter volumetric flask. Then, lastly, the distilled water was added and made the solution up to 1 liter. And next, we move to the preparation of starch indicator solution 5%. The first step, 5 grams of soluble starch was added to 100 ml of boiling distilled water in a conical flask by stirring. Then, the solution was then cooled down to use. Move forward, we move to the preparation of sample solution. The 2 ml of the raw solution was pipetted in a conical flask and 98 ml of distilled water was added to attain the diluted sample solution that is 50 times diluted. So last but not least, we need to estimate the vitamin C content by redox titration using the iodine solution. So the first one is 20 ml of the sample solution was pipetted into 250 ml conical flask and 150 ml of distilled water was added to it, followed by 3 ml of starch indicator solution. Then, the sample solution was titrated with 0.005 mol per liter iodine solution. Then, the titration endpoint was identified as the first permanent trace of a dark blue-black color due to the starch iodide complex. Then, the titration was repeated with further aliquots of sample solution until we obtain concordant result. So, in the previous preparation of chemicals, we had prepared starch and iodine solution. So, what is the function of both solutions? The first one is starch solution. Starch solution indicate the endpoint of the titration. The permanent color changes demonstrates the endpoint of the titration. Then, the iodine solution. The iodine solution functions as both mild oxidizing agent and the titrant. It reacts with vitamin C and reduces itself. What happens is the iodine oxidizes vitamin C into the hydroascorbic acid and is reduced to iodide ions as it drips into the lemon juice.
This is an example of the results obtained for the titration of ascorbic acid solution with iodine solution. The raw titration results obtained from 4 trials determine the amount of ascorbic acid in the lemon solution. Each final burette reading is subtracted with their respective initial reading to get the volume of iodine solution needed to reach the endpoint. By dividing it by the number of trials, which is 4, the average volume of iodine solution needed is calculated to be 1.6 ml, equivalent to 0.016 liter. The given data includes molarity of iodine solution 0.0015 m, volume of diluted lemon solution 100 ml equivalent to 0.1 liter, average volume of iodine solution 0.0016 liter, 1:1 mole ratio between iodine and ascorbic acid, and the dilution factor of ascorbic acid solution 50 times. These values are used to calculate the concentration of ascorbic acid. Next, I will be explaining the step-by-step calculation used. First, the moles of iodine are calculated using the formula number of mole equals the molarity times volume in liter, cancelling the unit L and obtaining 8 times 10 to the power of negative 6 mole. Next, using the balance equation of the reaction, the number of moles of ascorbic acid is the same as number of moles of iodine. Thus, the number of mole of ascorbic acid is also 8 times 10 to the power of negative 6 mole. After that, the molarity of ascorbic acid can be calculated by dividing the mole number of ascorbic acid by the sample volume. The molarity is calculated to be 8 times 10 to the power of negative 5 m. Lastly, the concentration is converted to milligram per 100 ml using the molar mass of ascorbic acid 176.12 gram per mole. The new concentration value is calculated to be 1.41 mg per 100 ml. Note that the dilution factor is 50. After multiplying by 50, it is concluded that there are exactly 70.5 mg of ascorbic acid in 100 ml of pure lemon juice.
Last but not least, titration is an effective volumetric analysis technique for determining the concentration of vitamin C in lemon juice. By measuring the volume of iodine solution need to reach the endpoint, we can accurately calculate the amount of vitamin C present in the sample. This experiment demonstrates how volumetric analysis can be applied in food analysis to determine nutrient content accurately and reliably. Through this experiment, We also gain practical experience in handling laboratory apparatus, identifying the endpoint, recording accurate data, and performing calculation. To improve the accuracy of the experiment, several precautionary measures should be taken. These include reading the burette at eye level to avoid parallax error, adding iodine solution slowly near the endpoint to prevent overshooting, ensuring all glassware is clean before use, and repeating the titration to obtain concordant reading. So overall, this experiment enhanced our understanding of volumetric analysis and is important in determining vitamin C concentration in lemon juice. So that's all from us. Thank you.